Hello everyone, in this video we are going to discuss about the extraocular muscles. So namely there are 7 muscles which we are going to discuss in this video. There are 4 recti, 2 obliques and 1 levator palpebrae superioris. So we will be discussing about the origin, insertion of supply and action of each of these muscles. You can very clearly see in this video all the muscles are visible. If you can see this one is levator palpebrae superioris. Below this is superior rectus. Just below this is superior oblique. If you imagine, this is the medial side, so this one is medial rectus, this one just towards the inferior side, this one is inferior rectus, below this is inferior oblique, and from this view we are unable to see the lateral rectus. So let's shift the view and you can see this one is here, this is lateral rectus. So all total 7 muscles we are going to discuss. So let's start with the levator palpebrae superioris, this muscle here. So we'll be discussing origin, insertion of supply and action of levator palpebrae superioris. So the first muscle we are discussing is levator palpebrae superioris. So as the name suggests, mostly the action of levator palpebrae superioris is the elevation of the upper eyelid. Now talking about the origin, so as you can very clearly see this part, so it is originating from the orbital surface of lesser wing of sphenoid bone. So from the lesser wing of sphenoid bone, the origin of levator palpebrae superioris is taking place. You can very clearly see this is the sphenoid bone, and from the orbital region of the sphenoid bone, the origin of levator palpebrae superioris is taking place. Now, if we talk about the insertion, so for insertion of the levator palpebrae superioris, it is getting inserted at the superior tarsus and skin of superior eyelid. So for that, you should know that superior tarsus where it is present. So from this image, you can see this portion, this one. This is the superior tarsus. So this whole is a superior tarsus, and you can very clearly see the insertion of levator palpebrae superioris muscle, this one. Here it is getting inserted. So for the origin, we have seen that it is inserted in the lesser wing of sphenoid bone, and the insertion is taking on the superior tarsus and skin of superior eyelid. So in this, you can see that levator palpebrae superioris, the origin and insertion. From the video also you can see where it is getting inserted and it is originating. See here, the superior tarsus is not visible. So here we can see that the superior tarsus is not visible, but the insertion of the levator palpebrae superioris is taking on the superior tarsus. And as for the origin, you can see here it is the origin of from the lesser wing of sphenoid bone. Now next in line is the origin of all the rectus. So we will be studying the rectus together. So as you can very clearly see, the superior rectus, inferior rectus, medial rectus and lateral rectus, they are originating from the common tendinous ring. So all the 4 rectus are originating from the common tendinous ring. Now if you can see, these are the 4 rectus. Very clearly you can see this one is superior rectus, the medial rectus, the lateral rectus, and this one is inferior rectus. This is how they are inserted. We will be discussing about the insertion a little bit later. Now if we talk about the origin, they are coming from the common tendinous ring. You can very clearly see, you can make this out that this is a common tendinous ring. Okay, so this is also called common annular tendon, or it is also called tendinous ring of Zinn. So this is the name given to this, though all these are attached to the common annular tendon. Now where is this tendon present, or where it is getting inserted, where in which fissure it is attached to? So this whole ring is getting attached to the superior orbital fissure. So this hole is getting attached to the superior orbital fissure, the middle part of the superior orbital fissure. So if you can make out from here, this ring is getting attached in the superior orbital fissure, and all these the superior rectors, medial rectors, inferior rectors and lateral rectors are getting attached on the tendinous ring, and that is getting attached on the superior orbital fissure. Now we will be talking about the insertion of these rectors. Now these four recti are getting inserted, as you can see. So these four recti, as you can very clearly see, are getting inserted on the sclera. So these all are getting inserted on the sclera, and it is a little bit posterior to the limbus. So majorly they are getting inserted on the sclera. So we have seen the insertion and origin of levator palpebrae superioris and also of the four rectus, that it is coming from the common tendinous ring and getting inserted on the sclera. Now we are going to talk about the superior oblique muscle. So the origin of superior oblique is taking place from the body of the sphenoid bone. So if you can make out from this here, this is a portion, the lesser wing of sphenoid bone, from where the origin of the superior oblique muscle is taking place here. So one important feature of superior oblique is that it is here, you can see this is a kind of pulley, okay, which is present on the trochlear fossa of the frontal bone. This one is a frontal bone. So there is a trochlear fossa. On this there is a pulley. Here you can. So the superior oblique is passing through the pulley and getting inserted. Now we will be talking about the insertion of the superior oblique. Now if you talk about the insertion, so insertion is taking on the sclera. Like the four recti, it is also getting inserted on the sclera, but it is behind the equator of the eye wall. So it's little behind, and it is getting inserted in between what? As we know that the insertion of superior rectus is taking somewhere here and the lateral rectus is taking somewhere here. So in between both the muscles, the insertion of the superior oblique is taking place. So you got that insertion and origin of the superior oblique. I know it's a little bit difficult, but if we can imagine a little bit, so it will be easy for us. So here we can say that the tendon passes through the fibrous ring I showed you, and it changes its direction and get inserted into the sclera deep to the superior rectus muscle. Now we are on the last muscle, that is inferior oblique. So if we talk about the inferior oblique, its origin is taking from the anterior part of floor of orbit. So from the anterior part of floor or orbit, or we can say that it is coming from the orbital surface of maxilla. So we also can say that it is coming from the orbital surface of maxilla. So here you can make out, this is the part of maxilla, this one is maxilla here. So it is coming from the orbital part of maxilla. So origin is from here. So we are talking about the insertion of the inferior oblique. So here it is originating, and as you can see, it is going below the inferior rectus and also here below the lateral rectus and getting inserted on the sclera here. So here this is the insertion of inferior oblique on the sclera. This is the insertion of superior oblique. Here is the insertion of the inferior oblique. So I hope all the insertion, origin and insertion of all the 7 muscles is clear. Now we will be discussing of the nerve supply and action. But as you can see, all the origin and insertion should be clear from this. Okay. So for the nerve supply, there is a mnemonic that is SO4 NLR6. Okay, so what this SO4 and LR6 indicates? It indicates that the SO is our superior oblique, 4 signifies a cranial nerve number 4. Okay, so which one is the fourth number? That is trochlear nerve. So SO4, so the trochlear nerve supplies superior oblique, and from LR6 we says that LR is our lateral rectus. So lateral rectus is supplied by the cranial number 6. So cranial nerve number 6 is abducens nerve. So except these two, all others are supplied by the cranial nerve number 3. So rest of all the other muscles are supplied by the cranial number 3, that is oculomotor nerve. I hope it's clear, and the mnemonic to remember that is SO4LR6. These are the exception, otherwise all are supplied by the oculomotor nerve. So this was the nerve supply. Now we are going to discuss about the actions of all the muscles. Now starting from the levator palpebral superior osseous, its action is to elevate superior eyelid. The only action that it has to elevate the superior eyelid. So for understanding the actions of all the muscles, we have to understand the movement of the eyeball. So there are 3 axes on which the movement of the eyeball occurs. The first one is the transverse axis, second is vertical axis, and third one is anteroposterior axis. So in this, the rotations takes place like on the transverse axis there is elevation. What we understand by elevation? It is the upward rotation. Like if we have to signifies is through the arrow, so this one is the upward rotation of the eyeball. Other one is depression. Depression is the downward rotation of the eyeball, like this. Okay, on the transverse axis, 2 actions takes place: the elevation and depression. Now on the vertical axis, the rotation is the medial rotation. Medial rotation or the adduction. How we will be showing the adduction? This means that towards, suppose this is the nose part, so if the eyeball is moving towards the medial side, so this is the adduction. And if we talk about the lateral rotation will be, if suppose this is the nose and it is going away from the midline, then this is the abduction or the lateral rotation, as you can see very clearly. Okay, and the other axis is anteroposterior axis. The 2 actions are intorsion or extorsion. Okay, for the anteroposterior axis, what are intorsion and extorsion? So when we are having a 12 o'clock position of the cornea, what is a 12 o'clock position? Means we are seeing straight. Okay, no deviation is there. So if the rotation is medially, that is intorsion, and when it rotates laterally, then it is extorsion. So unlike the adduction and abduction, there is the movement. Suppose this is intorsion and this like this is extorsion. We will be seeing this in the pictorial way, so we will be understanding it more. Okay, so these 2 things you understand, that there are axes and then there are actions of that. Now all the muscles we are talking about. Now if we talk about the muscles, superior rectus, the actions are it do elevation, adduction and intorsion. Okay, you have to remember this. Medial rectus, only one action, that is adduction. Inferior rectus, opposite to superior rectus. What is the opposite of superior rectus? That elevation is done by superior rectus, so it is showing depression. Adduction, same way, and instead of intorsion, it is showing extorsion. For the lateral rectus, it do abduction. Now on the superior oblique muscle, it depresses, abduct and intorsion. Okay, and inferior oblique, elevation, abduction and extorsion. So this is what the actions are. You have to remember these. For medial rectus, you can see. Now if we see here in this, it will be more clear now. For the medial rectus, the action is adduction. So it is going towards the medial side, adduction. Lateral rectus is doing what? It is doing the abduction, so it is going this side. Now for this side, if we see medial rectus towards the nose and away from there, that's the action of lateral rectus. I think this is clear. Medial rectus and lateral rectus action, adduction and abduction, that's only the action of the both the muscles. Now if we talk about the elevation and depression, we will be going towards action. Now elevation means upward rotation in all these three, this one and this one. The action is elevation. Okay, now elevation, what are the muscles which do elevation? Superior rectus is the muscle which is helping in elevation. Okay, so whenever we have to do elevation, what muscle will be coming in picture is that is superior rectus. Okay, always there is an elevation, superior rectus is there, so superior rectus will come in picture. Whenever the concept of elevation is coming, superior rectus will be there. Okay, so upward rotation or elevation, superior rectus is a muscle. Now one more muscle which is doing elevation is inferior oblique. You can very clearly see here, inferior oblique is the muscle which is doing the elevation. Now if we see from this diagram, okay, inferior oblique. So if the person is seeing here, you can very clearly see where the person is seeing. It's seeing means in the upward direction and little bit towards the left side. Okay, so inferior oblique is coming in picture. Here also the person is seeing upwards in the 12 o'clock position. This is the inferior oblique. And towards the right side, if the person is seeing in the upward direction, inferior oblique is coming in picture. So for the elevation, there are two muscles that are superior rectus and inferior oblique. For the elevation, the muscles which are required are superior rectus plus inferior oblique. Right, now next one is the depression. So for depression, which muscles is required? That is inferior rectus. So whenever we are talking about the depression is downward rotation. The person is seeing downward. So whenever we are talking about depression, the muscle is inferior rectus, and inferior rectus. Okay, so inferior rectus is coming in picture whenever we are talking about the downward rotation. What other muscle is required? That is superior oblique. The action of superior oblique is depression also. Yeah. So for superior oblique is required superior oblique, and here also superior oblique whenever the person is seeing in the downward direction. Okay, so this is a pure function. Now if we talk about intorsion and extorsion, so what muscle is doing intorsion? Intorsion is done by superior rectus and superior oblique muscle. And if we talk about extorsion, it is done by inferior rectus muscle and the inferior oblique muscle. So this all is the action of both the or all the muscles of the extraocular muscle. So this is the actions of extraocular muscles for elevation, depression, or adduction or abduction. So we have discussed about the nerve supply also, action and origin and insertion of all the extraocular muscles.